Welcome back to Unit 1, Chapter 4. We're going to go back to Section 4.3. If you notice, we skipped over the equation, solving the equation parts when we did the classwork. You probably wondered why we're doing that. Well, I want to get the factoring mastered first, because now we're going to use factoring to actually solve some quadratic equations. So after completing this lesson, I will be able to, that's you, solve equations of the form x squared plus bx plus c equals 0 by factoring. And number 2, find the zeros of equations of the form y equals x squared plus bx plus c. When you get done with this lesson, I really hope you say, why did you have 2 goals today, Mr. Kuhn? They really are the same thing. Solving equations and finding the zeros is the same exact process. We're really talking about the same thing in 2 different ways. So those are 2 goals. Make sure you have those down for you in your notes. Section 4.3, you can label this one solving. Last 4.3 was factoring. So that's how you can differentiate and not get yourself confused later. Is why do I have 2 4.3 notes? You're supposed to. Okay, solving functions by factoring. Okay, solving quadratic functions by factoring. Here are some terms that you're going to hear in this chapter: solution, x-intercepts, roots, zeros. They all mean the same thing. Okay, they're synonyms of each other. An x-intercept is the same thing as a solution, is the same thing as a zero, is the same thing as a root. So in one problem, I may ask you to find the x-intercepts. Another problem, I may ask you to find the roots. In another problem, I may ask you to find the zeros. It's really the same thing. We're looking for points. Draw a parabola here. We're looking for points for all of these where the values cross the x-axis. Where the values cross the x-axis. That's what we're looking for here. So in this case, our zeros would be 2 and -2. Okay. Our x-intercepts would be positive 2, 0 for that one. And -2, 0 over here. Okay. Our zeros would be -2 and +2. Our roots would be -2 and +2. Like I said, our x-intercepts, -2 and +2. I'll put parentheses around that. Solutions, -2, -2, and +2. So really, they're talking about the same thing. I'm trying to find these spots where they cross the x-axis. Tomorrow, in the next lesson, we're going to incorporate, obviously, instead of just being x squared, it'll be ax squared. You kind of see where this is going. Here is a big idea that is really simple. At least I hope it is really simple for you. It's probably something you haven't thought about too often because it's kind of like one of those well-duh expressions or property. But anyways, here it goes. If the product, it's called the zero product property. If the product of 2 expressions is 0, then A times B equals 0, then A equals 0 or B equals 0. So A times B equals 0 is kind of the expression. If the product of 2 expressions is 0, that's kind of the sentence put into a mathematical expression. Okay, taking English and putting it into mathese, if you were to say. But anyways, it's kind of a well-done one to me, because if 2 things multiply to make 0, one of them, A has to be 0, or B has to be 0, or both have to be 0. Duh, right? You're thinking, okay, this is algebra 2? I like this so far. Okay, but it is an important idea. It's important that we recognize this as we move forward, because that's going to help us solve by factoring. For example, if x plus 5 times x plus 2 equals 0, what can we conclude here? Well, what you have to do is think about it. You're like, whoa, this looks a lot harder than what you had on the previous slide. You have to think about this parenthesis, this binomial as being A, and you have to think about the x plus 2 as being B. If you think about it that way, which is perfectly legal, okay, a variable can represent an expression, that leads us to conclude that x plus 5 is 0, or x plus 2 is 0. And if we can do that, we can solve those equations pretty easily. Okay, x plus 5 equals 0, that's what you did 7th and 8th grade. X plus 2 equals 0. These are called one-step equations. I know you definitely did them in algebra 1 whenever you took that, whether it was as a freshman or in 8th grade. X plus 5 equals 0. We undo adding 5 by subtracting 5. So x is negative 5. X plus 2 equals 0. We undo adding 2 by subtracting 2. And we get x equals negative 5 and x equals negative 2. Okay? So remember we tie that in with the graph. Real quick, I want to show you something that's, as we go on, it might help you check your answers. First of all, you should check them algebraically every time by plugging them back in. When I plug in and I check it algebraically, when I plug in negative 5 for x, I get negative 5 plus 5 times negative 5 plus 2. Negative 5 plus 5 is 0 times negative 3, which is, let's show you, there we go, which is 0. So negative 5 is an answer. When I check negative 2, I get negative 2 plus 5 times negative 2 plus 2. That's 3 times 0, which is 0. So that checks. So that's how you do it algebraically. You plug your answers back into the original equation for x, one at a time. Notice I didn't plug negative 5 into one and negative 2 into the other. It doesn't work that way. You have to plug them in. Negative 5 for all the x's once. Simplify. Plug negative 2 in for all the x's once. Simplify. We got 0. That's what we wanted. We want, it was equaling 0. That's what we want. It's finding the zeros. That's worked out. Now you can also do it graphically. Okay? Graphically, I'm going to take the original equation. Hopefully you wrote it down. Delete these from the other day here. And we're going to put in x plus 5 times x plus 2. And we're going to graph it. And we're going to see where these values cross the x-axis. Well, it looks like pretty close to negative 2, and it looks like pretty close to negative 5 to me. But let's just make sure. We go up here. Negative 2 is a 0 on the table. And negative 5 is also a 0 in the table. So we can check it that way. If we go back to the graph, remember, if you hit second trace or calc and hit value, we can plug in negative 2. If we think that's a 0, we hit enter. It says y is 0. We can do it for the other one. Second calc value, we think negative 5 is an answer. We can plug that in. And it says y is 0 at negative 5. So there's lots of ways to check it. Okay? And we'll get more into solving graphically in a little bit, but that's just a way to check your answers as we go through here. So, now we're going to up the ante, so to speak. And we're probably not going to do each and every one of all of these examples, but we're going to pick a few out and just to practice. So go through this first one with me, doing it, and then as we go through, if I don't tell you to, feel free to just pause it, you try the problem, and then check your answer as I go through the explanation. Okay? So we're still going to factor these. We're going to look and say, can I divide a monomial out? For this first one, a, x squared plus 14x plus 48. Well, the coefficient of x squared is 1. That makes it, and no numbers are going to be pulled out. 48 is a constant. That means there's no variable next to it. So there's no variables that can be factored out. So no monomials for this one. So we go through the bottoms up process. See why we started with that? I wanted it in your brain, the bottoms up method. So we have 1x squared, so a is 1, c is 48, 1 times 48 is 48, and our b is 14. 1 multiplies to make 48 and adds to make 14. So I said pause it, list them out, see if you can figure it out. Hopefully you looked at this and you saw that 8 and 6 will multiply to make 48, and 8 plus 6 is 14. Obviously, you may have come up with more combinations. If you started with 1 and 48, a lot of people just say 48 divided by 1, 48 divided by 2 in their calculator. They try to find the combinations that way because they're not going to do the multiplication in your head. That's fine. You can use your calculator. You start dividing 48 by 1, by 2, by 3, by 4, until you get to a point where eventually you're going to start repeating factors. And then you'll have all the factors listed out. You can look for the pairs and eliminate that way. But this works. This is the combination we want. So we do the bottoms up part. x plus 8, x plus 6, or x plus 6 and x plus 8. What's a in this case? A is 1. If a equals 1, do we have to do bottoms up? No, we don't have to, but we're going to just do it to remind ourselves because in the next lesson we'll need it. 8 divided by 1 is 8. 6 divided by 1 is 6. And we get x plus 8 times x plus 6. Should we take my word for it that we're right? Of course, because I'm always right. No, we don't take my word for it because I'm always right. We FOIL it, or we use the box, or we graph it. We got to do something to check our answer. X times x is x squared. X times 6 is 6x. 8 times x is 8x. 8 times 6 is 48. Remember, you can do this in the box here as well. Same answer. X squared plus 14x plus 48, I believe, is what we started with. Checking off before I went back and looked. Yes, it is. So, our answer is correct. Let's circle it again. Okay? So, oh, wait, that's not our answer. That was our answer 2 sections ago, or 2 days ago, or yesterday, even. Oh, that's not what we're looking for. Oh, you were so excited, weren't you? We did have to check to make sure it was factored correctly. But remember, it says solve the quadratic equation. If I am solving, that means I'm going to find what the value of x is. I am not just factoring. Some of you in this room, when you get to a test and it will say solve, you will factor it out and it will look so nice and so neat. And I can't give you full credit because that's not the answer. If it says solve, what do we do now? Well, now we use the zero product property. Remember that on the last slide, the well done property? Zero product property tells us that if x plus 8 times x plus 6 equals 0, then x plus 8 is 0, and x plus 6 is 0. Actually, they said or x plus 6 is 0, but we're going to assume for both. And once you have this, we just solve each equation. Moving this down, I'm running out of room here. X plus 8 equals 0. What do we do to solve that equation? I subtract 8 from both sides. Over here, x plus 6 equals 0. I subtract 6 from both sides. So negative 6 and negative 8. How do I check it? Well, I plug it back in. Let's do it the fast way of plugging it back in. Let's go to y equals. Let's put our original problem in here. X squared. This is why I want you practicing with that graphing calculator at home. I want you practicing in class, because once you get used to checking this on the calculator, it's going to make your life a lot easier. When I graph it, here's the equation. We're looking for negative 8, negative 6. I'm going to make it more standard. Remember, zoom 6. Change my table. There we go. Hit zoom 6. That makes it negative 10 to positive 10 and on the x and y axes. We can see it crosses at both these spots. We think we have an answer. So I'm going to hit second calc value. I'm going to plug in negative 6. It says y is 0. I'm going to plug in negative 8. It says it's 0. We're good. Okay, so that's one way to quickly check it once you have solutions. You can probably look at the graph. You can also go to the table. If you go to the table, negative 6 is a 0 across from it. Negative 8 is a 0 across from it. One final way we can check this on our graphing calculator, and you might be seeing some other things that say zeros on there, thinking, can we use that? If I go to y equals and then y2 put a 0 there, just trust me on this, hit second trace. See where it says 0 on number 2? Watch what it will do for us. It says left bound. So I got to get my cursor on here. I'm watching my x's. Here it comes. It's way far away. So here's my point. I'm looking to get that 0. Left bound, remember we did this before for the max and min. We just have to get left of that 0. Put that little arrow pointing up to the right. It's saying, okay, look that way, and then we put the right bound. And these two arrows, they tell you, look between them. They're pointing at each other. Look between us. Look between these two spots. And then a guess, you just have to get reasonably close. You hit enter, -6, 0. I can do it for my other one. Let's try that again. Second calc, 0. Left bound, I go over to the other point. I go left of it, I enter. I get right of it, I hit enter. Get right on it where I think it is. And it says -8 for x and 0 for y. So that's another way to do it. I'm showing you multiple ways. Rewind it, practice it. Find one or more that work for you. It'd be great if you had more than one way to check it, because if you get bogged down with one particular method, you know, it's always better to have more than one way to do it. But these both work. So these are solutions. So we should circle these, and we should go back up here and uncircle this, because this is just the factoring. This is the reason why we factor. We don't factor, even though factoring is fun, we don't factor just to factor. We factor for a purpose. Yes, so quadratic equations. Okay, so once again, we're going to try B down here. Just as you go through this, you know, pause it right now. I want you to try this on your own. So go ahead and pause the lesson, and when you're ready to come back and check your answer, come on back and we will go through it together. Okay, so hopefully this one wasn't too bad. Once again, monomials, there are none. Nothing divides out of t squared, -3t, and -18 other than 1. So we go straight to bottoms up. We're solving by factoring. A times c, what adds to make b? 1 times -18, that's -18. B is -3. Notice c is negative. What does that mean when that last term is negative? Of course, that means that one of the factors is positive, one is negative. So keep that in mind. So when you went through, you probably made a long list. Hopefully you found that -6 and +3 were the combination that would work for this one. That works. They multiply to make -18. They add to make -3. We are in business. So T, I'm going to capitalize my T's because sometimes my T's look like plus signs when I make lowercase. So I know it's a lowercase t, but just to keep everything distinguished here, as I write sometimes I get even sloppier when I start going fast. So hopefully that'll avoid any confusion. So t minus 6 times t plus 3, or you could have done t plus 3 and then t minus 6, it won't matter. Bottoms up part, we divide by a equals 1 in this case. Is that really going to do anything? No, but we're going to practice it just so we remember when we get to tomorrow's lesson that we need to do this. So of course I would encourage you to check this by foiling it back out. Hopefully maybe in your head you're getting better at this. You can see we're going to get t squared for the outer terms. We're going to get -18 for the last terms. -6t plus +3t is a -3t, which is what we want in the middle. So maybe you're getting better at your head checking it. But if not, do the FOIL, do the box. Okay? What we're really looking at is this all equals 0, right? We're solving. We're trying to find x. So if you stopped here and said, ooh, I factored it, that's great, but it's not enough. I'm sorry. So to get the prize, to get the question completely right, we use the zero product property once again. Set each of these parentheses, these factors, each of these binomials equal to 0. We solve for t. Nice thing about these, they're all one-step equations. So we just undo addition, we undo subtraction by reversing the order of operations. We get t equals -6 and t equals -3. Those are our two solutions. You can check this by plugging these back in. If we do it the old-fashioned way, let's do it the old-fashioned way. Check. This is how Mr. Kuhn had to do it way back in the day. Here's my equation. T squared minus 3t minus 18 equals 0. If I check 6, then I'm going to put a 6 in for t. 6 squared minus 3 times 6 minus 18. So 6 squared is 36. 3 times 6 is 18, so negative 18, negative 18. I subtract 18 from 36, I get 18. 18 minus 18 is 0. That one checks. Now I do the same thing for 3. I plug 3 in for t. 3 squared minus 3 times 3. Now can I put this in my calculator? Yes, I can. It would be the same thing. 3 squared is 9 minus 3 times, oops, it's a negative. 6. This should be negative 3. My fault. Got going fast here. It's a negative 3. That's still positive 9 though. When you put that in your calculator, if you don't put parentheses around that negative 3, then you are going to get negative 9 when you square it. You have to put parentheses. Your calculator is squaring, then the negative. You want to multiply negative 3 times negative 3, which is a positive 9. Negative 3 times negative 3, once again, positive 9 minus 18. Once it's all addition, we go left to right. 18 minus 18 is 0. They both check. Try graphing them like we did before. If you don't remember how we did that, go back to this previous problem, rewind it, and see what we did here. But those are our answers. We can reliably say that these two check. We're good to go. Notice how I circled the answers. I would appreciate that. Any work you're showing by hand that you circle the answers, it's a lot easier for me to check it. Okay. Special products. Just really quickly do a couple of these. It's the same idea. You're just factoring to solve. It's using the special products properties in factoring to find the special products. So, excuse me, to find the solutions or the zeros, whatever they're asking you to do, x-intercepts. In this case, they're asking us to solve for t. So t squared minus 144, this, of course, is the difference of squares pattern, right? T times t, 12 times 12. So we get t minus 12 times t plus 12. I didn't capitalize my t's, so hopefully it'll look it out for you. We'll multiply that back out. When you FOIL it, you'll see you'll get t squared minus 144. So now we use the zero product property. T minus 12 is 0, or t plus 12 is 0. We get positive 12 over here, and we get a negative 12 over here. So we're just using these special products. I'm not going to go through a perfect square trinomial here because, in all honesty, you can just use bottoms up in those if you don't notice the pattern for factoring it and still get the same solution. Okay, but go ahead, go back and check these. I'm going to let you do that on your own. Check, plug them back in your calculator, see if you get the same thing. You should. 12 squared is 144. Subtract 144 is 0. Negative 12 squared is 144. Subtract 144, we get 0. So just showing you that we can use these special methods for factoring and solving equations as well. Okay, one last problem for this lesson, and it's just wording something different. Remember we said at the beginning we have two goals, to solve and to find the zeros. Well, now I'm asking you to find the zeros of y equals x squared minus 8x plus 16. How does this change our problem? It really doesn't. Because really what this is, what we're going to do to find the zeros, that means y is 0. When you're finding the zeros, that's the only way you can be on the x-axis is if y is 0. If you're thinking this is an x, y ordered pair, the solution. So in order to find the 0, we have to let y be 0. And what does this look like? It looks just like the problems we were doing. So we go ahead and we do bottoms up. So that's an important thing to remember. Zeros, find the zeros, solving, x-intercepts, find the roots, all mean the same thing. We're assuming we're solving this, setting the equation equal to 0, and then factoring and solving for x. Or solving for x in some manner. We're going to learn about other methods other than factoring as well. So a times c is 1 times 16, which is 16. b is negative 8. So what multiplies to make 16 and adds to make negative 8? Like I said, you want to pause this, try it on your own. I would appreciate that if you would. So when you're ready to come back, just hit play. Okay, hopefully when you went through, you found there's a bunch of combinations, but only one that we're looking for. I don't know if there's actually a bunch. There's maybe a couple. There's a few combinations that multiply to make 16, but only one that multiplies to make 16 and adds to make -8 plus -4, which is -8. That's our winner. Remember, if C is positive, like it is, 16 is positive, both the terms have to have the same sign, which is good because that cuts down on our possible amount of pairs that we can use. So we know that -4 is our solution, or our factors we're going to use, excuse me, not our solution. So we get x minus 4 times x minus 4. In fact, what we factor this into, if you can see, is a perfect square trinomial. That's what this started out as. You notice that 1x squared and 16. Those are perfect square trinomials. 16 is a perfect square. X squared is a perfect square. We just did it bottoms up. See, you didn't even notice it at the beginning, probably. Well, maybe you did, and you said, why are you going through this? It's too easy. It's going to be -4, -4, perfect square trinomial. Either way, we got there, didn't we? This is not our solution, though. Our solution is when we use the zero product property, and we set each of those binomials, each of those factors, equal to 0, and we solve for x. Since this is a perfect square trinomial, what happens? Our answer repeats. So x is 4 and x is 4, which just tells us there's only one solution for perfect square trinomials. And we'll notice that when we graph this equation, how many times do you think it's going to touch the x-axis? Well, I'm typing this in. Just think to yourself, how many times is it going to touch the x-axis? How many times did it touch the x-axis when we had two solutions? It'll touch twice. We have one solution, so how many times is it going to touch on this graph? What do you think? Looks like it only touches one time to me. And when you go to the table to check your answer, you said 4 was the answer. Well, I said it, but hopefully you did too. When you look at 4, that's the only place it touches. Okay, it really touches at the vertex, if you notice. The values start repeating when you go left or right of 4. So that's kind of how graphically it can help you. If it crosses once, there's one solution. If it crosses twice, there's two solutions. If it doesn't cross, well, we'll see what happens. There's no real solutions, as we'll find out shortly. So remember back to your goals at the beginning, the targets at the beginning of this lesson. Hopefully you feel comfortable solving equations in the form x squared plus bx plus c equals 0 by factoring. And you have discovered that finding the zeros of an equation, y equals x squared plus bx plus c, is really the same thing as goal 1. So really, we have two goals listed here, but it's the same thing. We're going to factor to find the zeros, to find the solutions, to find the x-intercepts, to find the roots. We'll see you in class tomorrow.